Hi everyone, in this video we'll be going through algebraic problems. And this is the first example. This particular question, we're going through question 6 in our worksheet and it involves a pool and two different holes. I believe many of you have seen such questions before. So this pool has a capacity of 120 liters and there's hose A can fill up at X liters per minute. So you need to understand the rate at which hose A can fill the pool up is X liters per minute. And what we do here is actually to introduce old concept of our DST, but we're going to generalize it a little bit. Instead of writing DST, we're going to write these three letters, QRT, Q, R, and T. And because we're talking about hose A, you can write about rate of A, time of A, and the quantity is the same, which is the pool itself, and it's 420 liters. And we have rate of A, which is X liters per minute. That's the rate. So to find the time, if you understand the triangle, it's just quantity over rate. I'll write down here once, quantity over rate. So you will get your 420 over X liters per minute. So you get this amount of time for hose A. Once you understand the pattern, for question B is usually quite straightforward. You can replicate the triangle again, but instead of having A, you can annotate it to have B. Yes, you do that part. Rate for B and time for B. Of course, they are referring to the same pool, which is a capacity of 480 liters. The only difference is that hose B is 6 liters less than as opposed hose A in terms of its flow rate per minute. So what's going to happen here is that since it's slower by 6 liters per minute, its rate will not be X, instead it will be X minus 6 liters per minute. Right? And same thing here, you can have your time for B, which is just, if you follow the working, quantity over rate. Okay? And that's answer for A and answer for B. Okay, to tidy up, it will look something like that. Right, let's continue for question C. Given that the difference in the time taken between the two hoses to fill up the empty pool is 5 minutes and 50 seconds, form an equation. Alright, so we need to understand something. Who is longer? Who takes a longer time to fill up the pool? Because hose B is slightly slower. Remember, our rate is X minus 6 liters per minute, so it's slower. So time B will definitely, time for hose B to fill up the pool is definitely more than the time needed for hose A to fill the pool. So we'll do the following. Time B minus time for hose A to fill the pool equals to 5 minutes and 50 seconds. So it's important for us to write the units in because our units for the timing is all in minutes. So we have to do a bit of change now. Once you do this, you can replace it with the relevant expressions. So it's 420 over X minus 6. There's the time B takes to fill up the pool. And minus the time for A to fill up the pool, which is 420 over X. And now we have to transform this into minutes. So it's just 5 out of 550 out of 6. Let's work on both sides at the same time. Next, I will make them the same denominator by drawing a long fraction line. It's X bracket X minus 6. And my 420 from the first expression will multiply by an X. And the 420 from my second expression will multiply by an X minus 6. On the right hand side, I will tidy up a little bit more. 50 over 60 is just 5 over 6. Or maybe I'll do a bit of working by the side instead. We know that this is 5 over 6. Because we're going to anticipate a cross multiplication, what we will do is to change it into an improper fraction, 5 times 6. So it's 35 over 6. Let's continue. If you expand, multiply it in, you get 420 x minus 420 x plus, because negative times negative, and it will give you 2520 over, we're going to expand the one below as well, x squared minus 6x equals to 35 over 6. Realize that 420x and minus 420x will cancel each other. So you get the following, equals to 35 bracket x squared minus 6x. expand 15120 equals to 35x squared minus 210x. All you can do is bring everything to the right hand side first. 0 equals to 35x squared minus 210x minus 15120. And keep in mind, you're working our way to this particular equation. And realize that x squared is just 1x squared. So let's divide everything by 35. Divide everything by 35. At the same time, we're going to shift the numbers around. So it becomes x squared minus 210 divided by 35. I get 6x and 15210. 15120 divided by 35 gives me negative 432 as well. I move everything to the left hand side to make it look at this equation. And that's what we want. Sure. In the next section, they ask us to solve the equation. Hence, solve the equation x squared minus 6x minus 42. 432 x squared minus 6x minus 432. We can use our calculator method and check whether it's a rational answer first. And it gives you x minus 24, x plus 18. Split them up. X minus 24 equals to 0, or x plus 18 equals to 0. X equals to minus 18. X equals to 24. Okay, conclude x equals to 24 or negative 18. In this juncture, you are not allowed to reject any answers because there's no context of rejection. It's basically just an algebraic question. So there's no context yet. So don't get too excited. But for question E, it says hence. And we know that x is a rate because remember, it's x liters per minute. And they are contributing water into the pool. So it cannot be a negative answer. So you have to say reject x equals negative 18. Therefore, x equals to 24 liters per minute. And what do they want? Find the time taken in both minutes, in minutes, if both hoses are used to fill the pool. So we need to find the combined rates. So for the rates of A plus B, you need to take 24 liters per minute, which is the rate of A, plus the rate for B, which is 6 liters per second, 6 liters per minute lesser. So it's 24 minus 6. This is the rate for B. Altogether, they will have 42 liters per minute. And now we can find our time, A plus B. Recall that it's just a DST triangle. So you take the quantity to be 420 liters, and the new rate of combined rate is 42 liters per minute. So you can find the time, which is just quantity over rate, which is 420 over 42. You get 10 minutes. Right, that's all.